So in this video, we're going to talk about how to solve a quadratic equation using the square root method. There are many ways to solve quadratics. We've already talked about graphing. You graph it and just see where the x-intercepts are. But that doesn't always work. It's not always the most efficient. So today we'll talk about the square root method. There are other methods that we'll get to as well, but square root method today. It's called the square root method because literally you take the square root. You'll see in a second. For example, here's a quadratic. Remember, a quadratic means the degree or the highest exponent is 2. So this is a quadratic, pretty simple one. And square root method just means you're basically just going to solve like you always have. If I want to find x, then I literally just get x by itself. For example, imagine that this was x minus 4 equals 0, just a linear equation. If I was trying to solve this, I would just get everything away from x until I have x by itself. I would add 4, and then I just have x equals 4. This is going to require just one more step. I'm going to add 4 to both sides. That will leave x squared equals 4. And then to get x by itself, I have to undo this squared here. And the inverse, or the opposite of squared, is square root. However, when you square root something, it could come out positive, but it could also come out negative. So I'm going to put this little plus minus here, which says this actually represents two numbers, the positive square root of 4 and the negative square root of 4. Square root of 4 is 2, so this represents positive 2 and negative 2. And now I have x by itself. The square root and squared cancel, and I have x equals positive 2 and x equals negative 2. It's two solutions. Let me be clear on why this is the case. If I do 2 times 2, it gives me 4. That's why the square root of 4 is 2. But negative 2 times negative 2 also gives me 4. That's why the square root of 4 is also negative 2. So you actually get two solutions. And anytime you square root a number, you want to do the positive and negative version. If you want to write them out separately, you can. X equals 2 and x equals negative 2. Those are, this and this mean the same thing. You can always check your work, make sure it worked. If I take 2 and plug it in for x, does 2 squared minus 4 equal 0? It should. Does negative 2 squared minus 4 equal 0? And it should. Just want to show you that this matches what we found with graphing. If I graph x squared minus 4, I see that it hits the x-axis at negative 2 and positive 2. Those are its solutions, just like I found here. Sometimes these solutions are also called roots. They're called roots because you take the square root to find them. They're also called zeros because it's where it equals 0, and they're also x-intercepts. All 4 of these words mean the exact same thing. So just be on the lookout for that. If it asks for roots or zeros, it's just asking you to solve it. I want to remind you, as you are solving equations, you work backwards of order of operations. So you got to get rid of the addition and subtraction first, then you get rid of the multiplication and division, then the exponents, then the parentheses. So that's what we did here. We got rid of addition first, then we dealt with the exponent. Because you're undoing things, so you go backwards of the order of operations. All right, let's try this one. So again, I'm just going to solve it. I'm just going to get y by itself. So I'll add 48 to both sides. So 2y squared equals 48. Next, if I'm going backwards in order of operations, I've got to save the exponent till the end. The next thing that needs to go is the 2. And since I'm multiplying by 2, to get rid of it, I'll divide by 2. Leaving y squared equals 24. And then to get rid of squared, I'll square root. Don't forget, when you square root, it could be positive and it could be negative. That's going to give you two solutions. So now y is by itself, and it equals plus or minus square root of 24. You can get a decimal out if you want, but I'd rather you leave these in radical form. But it's best to leave them as a simplified radical. This actually will simplify some, because 24 breaks into 4 and 6, and the square root of 4 is 2. So 2 root of 6 would be my final answer there. It's still plus and minus. So that's my final answer, positive 2 root of 6 and negative 2 root of 6. Let's try a little more complicated one here. Remember, again, I'm going backwards of order of operations, so PEMDAS. Addition and subtraction comes first, so I'll deal with this first. Leaving 1/2, x plus 8 squared equals 18. Next comes multiplication and division, meaning the 1/2 times this stuff, that needs to go next. To get rid of 1/2, you could divide by 1/2, but that feels a little complicated. To get rid of 1/2, that's really like dividing by a 2. So to get rid of that, multiply by a 2 on both sides. Because 2 times 1/2, that just cancels out, leaving x plus 8 squared. 18 times 2 would be 36. Next, if we're going backwards here, comes exponents. So I'm going to have to square root this whole thing to get rid of the squared, leaving just x plus 8. And I also need to square root this side to keep it balanced. Don't forget plus and minus when you square root. So this equals plus or minus square root of 36. The square root of 36 is 6. The square root of 36 is 6, and I'll leave the plus or minus there. This is where it gets slightly complicated because to finish this up, I'm going to need to subtract 8. And so it feels like the answer should be 6 minus 8 is negative 2, so it feels like the answer should be plus or minus negative 2. First of all, that doesn't make sense. Here's the thing. Positive 6 minus 8 and negative 6 minus 8 are going to give me very different answers. And so at this point, if you're ever going to do anything else with the plus or minus stuff, you need to split it up. So go ahead and split this up into positive 6 and negative 6. And now when I subtract 8, it'll make a little bit more sense. Positive 6 minus 8 is negative 2. Negative 6 minus 8 is negative 14. Those are my final two answers. You may want to check and make sure that it works. You could subtract 16 from both sides and then graph it and see if this is where it hits the x-axis. You could also plug in negative 2 and negative 14 and see if it works. For example, if you do 1/2, negative 2 plus 8 squared minus 2, I just put in negative 2 here. Will that actually equal 16? And it should. Same thing if you put negative 14 in here. It should also work, just if you want to check your answer. All right. Sometimes you might get something that doesn't work at all. For example, instead of x squared minus 4, you may have had x squared plus 4. If we try to solve this, we're going to get x squared equals negative 4 and then square root it, but you actually can't square root a negative. It doesn't exist. And so this has no solution because we're trying to square root a negative. You can see that on the graph. Here, if I graph x squared plus 4, see how it has no solution? It doesn't hit the x-axis.